We're going to be starting chapter 3 now. So 3.1 is lines and angles. First things we need to understand about lines are parallel lines and skew lines. So instead of talking about the definitions, let's go ahead and show you what they are. So you guys already know what parallel lines are. So if I go ahead and look at this rectangular box, they ask us to find which segments are parallel to AB. So AB is right here. You guys should already know what lines are parallel. They're in a coplanar, and it says here, our definition, I have it, is coplanar, and they do not intersect. So it's something you already should know. So what lines are parallel to AB? Well, the first one I could say is CD, and then I can also say it's EF. So we're going to go ahead and we're going to write those answers down. Now the symbol for parallel is two vertical lines like this. Okay, so the symbol for parallel means this. So we're going to say AB, segment AB. So AB with a straight line type on top, it's going to be parallel to DC. And we can also say that AB is parallel to EF. Don't forget the little line on the top to represent the segments. So those segments are parallel. That's something you guys should know. What is new here is that there is another one that you can't see, or you haven't never noticed. The other one would be HG or GH. And you might be asking, how is that possible? Well, imagine you slice the rectangle, okay, by the diagonal. And so you end up with this right here. I'll highlight it in green. I end up with this surface, this plane. So this plane, okay, is another flat. Remember, it's got to be parallel. So AB would make HG parallel. So there's this third one you probably missed, and that would be our third line that is parallel. So therefore, we're going to say also that AB is parallel to HG. Skew lines. Skew lines are a little bit difficult to explain. So what I'm going to do, for part B, which segments are skew? Okay, skew are lines that are non-coplanar, so they're not on the same plane, and they are not parallel, and they do not intersect. The best example I can talk about what are skew lines are airplanes. So if you have an airplane, so let me draw just an airplane on the sky, okay? And it's going straight on the sky at a certain altitude. So the altitude is our plane. So it's going to go straight, and what a skew line is like planes that you don't want to crash. So here's your plane going straight like this, and then you might have another one at a different altitude, a different height. So there might be one going down over here, and they won't collide because they're in different altitudes, they're at different heights. So that means that the second plane, the one underneath, will never crash with the one on the top because it's at a different height. So that's the definition of skew. You want something that will not intersect. Okay, so now let's look at this example. Which segments are skewed to CD? So going back to CD, here's our CD line. And I can only use lines that cannot touch CD. So let me go over in red, highlight which ones cannot work. This cannot work. It'll crash with line CD. So imagine CD is your plane. So I'll draw up a plane. And you don't want this plane passing through CD crashing. So line CG cannot work. So that one's not going to work. DH cannot. It will intersect that line. Okay. Now I can also not use BC or AD. Those lines can touch the one in yellow, so those don't work. Now remember, the definitions say they're also not parallel. Well, another line that is parallel is AB, and EF. Like I showed you before, EF, if you cut it diagonally, this is a plane. So those lines don't work. So that means that the only lines that are skew are AE, BF, EH, and FG, those in green. So those are our skew lines. These are lines where if there's another plane passing by, it will not interfere with this plane. Okay, and the last one I missed here is EH. Again, EH is parallel to CD, so those lines won't work either. So that means only these 4 lines would work. So I'll go ahead and write them down. So the only lines that are skewed would be AE, BF, EH, and FG. Okay, so that's probably the best way to show you what a skew line is. They're lines that will never touch that other line in a different plane. All right, let's move on to problem 2. Okay, before we move on to problem number 2, we need to add some new definitions here of angles, and specifically pairs of angles. So let's say I have 2 lines, and let's call the first line L. And then I have a second line. We'll call that M. Now, whenever a third line crosses these 2 lines, which is in blue here, that is called the transversal line. Okay, so that's called the transversal line, and we'll call that T. And what happens is you're going to end up with angles that are being formed. So I'm going to go ahead and label those angles. So we'll call those 1, 2, 3, 4, 5, 6, 7, 8. Doesn't matter how you label them, okay? But you want to label each of these angles that are being formed. So there's an angle being formed here, an angle 2, here's angle 1, and so forth. There are 8 angles being formed. All right, so the first thing we need to know is the definitions of these names, okay? But here's some few things we need to go to highlight. Anything in between L and M, so in between, that's all of this, okay? Those are called interior angles. Now, anything outside of the lines, of those 2 lines L and M, those are going to be the exterior angles. So these angles right here are known as exterior angles. So now let's go ahead and, based on this information, we're going to go ahead now and look at 4 new definitions of pairs of angles. The first set of pairs of angles are called alternate interior angles. Now, don't worry about this, writing all this stuff down. It's already in your notes, but I just want you to pay attention so you could understand what the definitions are. Alternate interior. So the first thing you notice is the word interior. Interior, from what we just talked about, are anything in between the lines. So angles 3, 4, 5, and 6 are interior angles. Alternate means they're on the opposite side of the transversal line. So they alternate. So the ones that I'm talking about are going to be 4 and 6, 3 and 5. Those are pairs of alternate interior angles. So angles 4 and angle 6 are alternate interior. Angles 5 and 3 are called alternate interior. Okay, now we're going to talk about alternate exterior angles. Exterior angles are on the outside of angles L and M. So we're talking about angles 1, 2, 7, and 8. Well, angle 1 and 7 all alternating on the other side of the transversal line. So 1 and 7 are alternate exterior angles. So we'll write 1 and 7. And that's a pair of alternate exterior. 2 and 8 alternate and are in the exterior, so that therefore those two angles are part of the alternate exterior angles. Okay, another set of pairs are called corresponding angles. Now, corresponding is a little bit difficult to explain, but if I were to take line L and I landed it exactly on top of line M, the result is that angle 1 would land on top of angle 5. So they correspond to each other. Angle 2 would land on top of angle 6. Angle 4 would land on top of angle 8. And angle 3 would land on top of angle 7. So that's the definition of corresponding. If these two lines were on top of each other, they would correspond to each other. So that would mean that angles 1 and 5, angles 2 and 6, angles 4 and 8, angles 3 and 7, all those would land on top of each other, so they correspond to each other, and that's called corresponding angles. Alright, the last set of pair angles based on this transversal passing through these two lines are called same side interior. Again, the interior angles are the ones that are inside. So 3, 4, 5, and 6 are all interior. Same side interior means they're on the same side of the transversal line. So that means that it would be angles 4 and 5. Those two are on the same side. So angles 4 and 5 are that first pair. The other pair would be 3 and 6. Those are on the other side of the transversal, so those are same side interior. So we're going to use these 4 definitions and their pairs to eventually help you solve problems. For now, we want to be able to identify them. Okay, so for problem number 2, now we're going to use those definitions to identify the angle pairs. Which pair are alternate interior? So interior means on the inside. So that means we're going to be using angles 2 and 6. And we're going to use angles 3 and 7 as our alternate interior angles. Okay, now let's move on to the second one, which is a pair of alternate exterior angles. Okay, so they have to alternate and be on the exterior. So that would be 1 and 5. They alternate and those angles are on the exteriors. The other one would be 8 and 4. Those are alternate and they are exterior. The next set of pairs are same side interior angles. So same side, 6 in the interior, and on the same side of the transversal, that would be that pair, and it would be 3 and angle 2. That pair would also work. Alright, the last set of pairs are corresponding angles. Those are if I were to take line M and I would put it on top of line N. So if that happened, then that means that angle 1 would land on top of angle 3. And so those are the corresponding ones. It would also mean that angle 2 would land on angle 4. It would also mean that angle 5 would land on angle 7. It also means that angle 8 would land on top of angle 6. So those are my corresponding pairs of angles. Okay, so those are the ways to identify angle pairs for these set of 4 new vocabulary. This is our last problem. What I need you to do is to make sure you understand these and go back and reference back to what they are. Look at your notes. Those definitions are in there so you could see which pairs belong to which. Okay, till then, we'll see you tomorrow.